Welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, January 14th. Looking at significant wave heights for the North Pacific Ocean, we see a pretty active pattern. Clearly, swell is plowing into Hawaii. Surf heights in the 20-foot range Hawaiian are being reported. And you can see new gale energy is trying to evolve off the California coast, seas in the 28-foot range, but not expected to get a whole lot higher than that. This is a mixture of remnant energy from a storm that pushed over the dateline to the east, and then a new gale that's trying to form from its remnants. Let's get into the details. The storm that produced this swell started developing off the Kuril Islands on early Wednesday morning, 38-foot seas, as you can see, building quickly to the about 47-foot range, but still pretty far to the north. And then the system started falling south, with seas in the 45-foot range pushing over the dateline, moving into close proximity north of Hawaii, with seas still in the 39-foot range. What is that right there? It's 300 nautical miles every 5 degrees north, so that's only about 600 miles out. And what was that? 38-foot seas aimed well at the Hawaiian Islands. Large swell, as we mentioned before, has hit the Hawaiian Islands. You can see it there impacting the islands. That was on Saturday. And then into Sunday, here we are currently, and that's where we stand right now. Remnant seas and the beginnings of a new small gale trying to organize northeast of Hawaii. Lots of swell energy pushing towards the U.S. West Coast. Impact expected on Monday and into Tuesday. Winds will be an issue because there is a front associated with this. We'll get into that in a minute. A quick look at confirmed sea heights from the storm. So we're at Wednesday 12Z satellite. Jason 2 satellite made a pass over the western quadrant of the storm. Seas there were, per the model, in about the 40 to 41 foot range. The satellite recorded a 15 reading average of 44.5 feet. So that's actually higher. 40.5 feet, so that's actually about on track with what the model said, with one reading to 44.5 feet, so the model was doing a good job with that pass. Another pass occurred just 6 hours later, this time over the eastern quadrant of the storm. There, seas were expected about 39 feet roughly, and you can see right there the, here we go, max average measurement, 15 reading average, 35.3 feet, with a peak reading to 39.8 feet. So maybe the model was overhyping it just slightly, but not too much. Then there was this troubling pass at 12Z on Thursday. The satellite went right over the core of the storm. Seas there should have been, 40, 41, 42, 43, 45, about 45 feet solid. But notice this, the average reading was only 37.4 feet, and then the peak reading was 45.7 feet. Troubling. And yet one more pass on 6C Friday over the eastern quadrant of the storm. Their seas were about 32 feet roughly. The satellite confirmed max average reading 28 feet, probably right in that area, and the peak reading 30 feet at 36.5, so that would have been somewhere right around in here, and 166, somewhere right in there. So again, the satellite suggested the model was overhyping it a little bit. And yet another pass on Friday, 18C, pretty much close to the core of the storm. Seas there, 31, 32, 33, should be about 34 feet. Average reading, 34.8 feet, so right on track with one peak reading to 40 feet. Interesting how sometimes the satellite passes right over the core of the storm, sort of underestimates it, and other time is right on track. What that typically is associated with is cloud cover. You get some bad readings, and so we try to filter out bad readings, and what you end up with is less height, though higher quality readings, so you need to take that into account when looking at this data. Needless to say, solid swell has already hit Hawaii and is pushing towards the U.S. West Coast. But as we mentioned before, weather will probably be a bit of an issue up into, let's say, from Monterey Bay northward. South winds, rain, north winds, the jet stream. Well, you'll see how it's going to play out right here. So here we go. Jet stream level winds. We're looking for the presence of trough. Remember, these winds up about 30,000 feet help support the formation of gales. When they do form, help direct their track. Well, clearly, we have a good, solid, cohesive jet stream pushing flat off of Japan over the date line, building to 1, 2, 3, 4. What's that? About 170 knots, forming a trough, a dip in the jet. That's what we want right there. That helps support counterclockwise flow aloft and down at the surface. And of course, that's the hallmark of low pressure or storms. And storms, of course, generate wind. Wind generates swell. And when swell radiates away from the fetch area, it produces swell when it arrives at your beach. So, clearly defined trough is present in the Gulf of Alaska, being fed by 170 knot winds. Notice, here is they call it ridiculously resilient ridge, the last bits of it, trying to hold on over the U.S. West Coast. But that is to be short-lived. In fact, here we go. Into Monday. Notice the trough almost starting to push into Northern California. Jet stream level winds pushing right over the San Francisco Bay Area, and that is the harbinger for weather. Now, if you want clean big surf, that's not a good thing. If you want rain and snow, that is a good thing. So it's kind of a mixed curse and blessing here all at the same time. Rolling this out, jet stream continues. Notice the trough still in the Gulf of Alaska, though kind of pinched off and kind of strange looking. Wind still feeding it, jet moving into the Sierras, and some potential for swell generation. Now here we go again on Tuesday. Another trough looks to be carving itself out, and there you go. Sure enough, in the Gulf of Alaska, that would support storm formation yet again, and that too rolls into the Pacific Northwest, and almost a secondary trough developing behind that on Thursday. And that too looks like it's bound for Northern California. Notice the jet starts splitting on Friday over the date line. Not so much wind energy, things backing off, but over Japan, another batch of winds, 140, 150 knots, trying to carve out a little trough right there, maybe supportive of gale development. Roll this out some more. Look at that. Come Friday night, trough pushing right over the U.S. West Coast into Northern California, the Lake Tahoe region. Hopefully, if it holds true, some weather and rain and precipitation will result, making in snow. Anyway, continue on out. Troughiness continues in the Gulf into Saturday night and even into Sunday. The split in the jet, not too bad, does it? It just sort of pulls apart a little bit, but the jet's trying to hold itself together back over Japan, and then there we are, a week out. The jet still basically cohesive, running from flat west-east across the North Pacific at about 33 north, something like that. So, the first real favorable push of the jet stream all year, and the first indication that the ridiculously resilient ridge is gone, at least for the moment. But we know that we're in La Nina. We know there's a broad pool of cool water down here, and we know that typically does not help the jet stream at all. Let's take a look down at the surface, see what effect the jet stream is having on the ocean, specifically in regards to wind. Here we go. Surface level pressure, surface level winds. We know there's some little gale trying to organize. The jet stream's got a bit of energy right here. We see 30, 35 knot winds pushing to the east, and this is positioned north of Hawaii. Not doing a whole lot, though. And then we see, another little batch, but not like a defined gale or anything really organized. More like a low pressure cell. Yeah, it's a closed low, but you need 35 knot winds. We don't have it, so it doesn't even reach gale status. 30 knot winds, pushing off to the east, targeting California. And we get into Monday. Notice it kind of wraps up a little bit there. Probably energy into the Pacific Northwest. Then we have a new low developing Monday night. Where's that? Just west of the date line. 50 knot winds. That would make it a storm. And continues pushing east. Probably spraying a little bit of energy towards Hawaii. Little sliver of 55 knot winds into Tuesday morning. Broader area underneath the tags there. You can see it was at probably about a 980 millibar low. Not very deep, not very large, but still 55 knot winds makes it a storm. And there you go. You can see the winds even better come Tuesday night into Wednesday, just spraying the entire U.S. West Coast with swell energy. At least that's the expectation. Still storm status into Wednesday night, then finally fading off of British Columbia on Thursday. Look at that. Still going, though. 40, 45 knot winds. Secondary little patch energy trying to develop right behind that. This is a pretty well-entrenched storm system. Notice high pressure here, too, forming a gradient. And that'll probably set up north. So you certainly have your south winds ahead of all the fronts, and then you get get high pressure, clearing high pressure, north winds behind that come late Friday into Saturday. Still, persistent low pressure even on Saturday off the Pacific Northwest. It just doesn't stop. Plenty of swell production potential there, but with rather poor conditions, I'd say, from San Francisco northward. And we'll roll this out. Then things finally start moderating 180 hours out, and likely the storm track will fall apart at that time. So what's the effect of those winds on the ocean surface? Well, 28-foot seas. Some of this is a mixture of previous swell energy. Some of it's new swell energy trying to be generated. But remember, winds are only about 30 knots in this area, so don't expect to see a whole lot. And there you go. We're into Monday, and we're down to like 26-foot seas, pushing towards the U.S. West Coast. Next system starts developing come Tuesday and wraps up pretty good. What are we at? 44-foot seas, and it's supposed to go to 46-foot. And then 48-foot on Wednesday morning and holding there, pushing towards there. Oh, and even more, 50-foot seas off of Oregon on Wednesday night. Now, the assumption is there's a lot of wind energy also along the coast. Don't think any of this will be rideable, but you certainly don't want to be in any sort of out on the ocean in any sort of a boat anywhere near this monster. Good solid raw gnarly swell energy impacting the coast Thursday, and this is just going to go on for a little bit into Friday and Saturday. There's your secondary fetch and 30-foot seas, that pushing into the coast as well. And then with that, everything pretty much goes to sleep. That's the last blast. The atmosphere sort of blows its top, and then we go to sleep for a little bit. Just a quick look at winds as of right now. Very high level. You can see south winds already building over out of California waters. And by Monday, south winds. Now this is, 15 knots there, but you can expect from Monterey Bay northward some sort of south winds in effect. That continues into Monday. Tuesday, supposedly, things let up with a little bit of north winds. Maybe there's a window there, maybe. But there's our next system building off the coast by Tuesday night. And by the time you get to Wednesday, probably some sort of south winds will develop ahead of that front as well. In fact, there you go. By Wednesday, 10 a.m., south winds in control, probably from San Francisco northwards, and not very far out there. You're like 600 nautical miles out from San Francisco, and it's storm force winds. Also notice trades. Here's high pressure building trades pushing hard into the Hawaiian Islands at that time. Just roll this out. Again, Thursday, more south winds, and then Friday, the high-pressure northwest winds start pushing 20 knots, even down into Southern California Friday night, maybe 30 knots in a little pocket right there out over the Channel Islands. And then yet another front. Now, notice high pressure right here trying to perform a little ball of protection. But the thought is, even if it is protected, sea state's so agitated, the best bet is to find some protected break to surf. Or certainly Southern California would qualify as that sort of location. And then a quick look at precip, specifically California. So there we go. First little bit of rain forecast maybe Monday night. Not very much, just barely glancing San Francisco, mainly for Northern California. There we go, a little bit of rain up into Tahoe and San Francisco into Tuesday, but that pushes out pretty quick. Second system, stronger, starts setting up Thursday midday, Thursday afternoon rain, some snow maybe in the higher elevations of the Sierra, and then pretty strong, looks like a good snow perhaps event for the Central Sierra come Friday. It snows all day Friday and then starts clearing out Saturday, and then perhaps a little bit more. You can see it building to the north for Sunday into Tahoe. So here's our long-range outlook for the Sierra, Squaw Valley in particular here, showing you can just see amount of snow over time. We're talking come January 22nd, 23rd, off the charts. We thought 96 inches was more than enough snow. We'd never run off the chart, but apparently it has. Here you go, 106 inches. If you believe that, I've got some swampland I want to sell you. But still, it gives you a general sense that wetness, snow, looks to be in the forecast, and that's a good thing. And then at Mammoth, further south, only 12 inches. That seems a little bit on the short side, given what we saw on the models. Maybe some sort of an error going on here. All right, what's going on long term, specifically with the MJO and, of course, La Nina? Let's get into those details. As usual, we start off looking at the MJO, looking for what's happening with the NJO, and to do that, we look on the equator. Winds on the equator, East Pacific here, West Pacific here, that's New Guinea. This winds from the TAO buoy array, 5-day average winds. You can see east winds, trades, pretty solid the whole way across the Pacific, though a little bit weaker in the Kelvin wave generation area. Kelvin wave generation area from 135 east to 170 west, 5 degrees north and south of the equator. You look right in here to see what's happening with the winds, and that tells you what's going on with the MJO and sometimes with El Nino. Here's anomalies, difference from normal for this time of year. Kind of a normal pattern we're looking at the direction and the size of these arrows, but you see as you get into the Kelvin wave generation area, winds out of the east, a little bit stronger than they should be, and that's a typical sign of the inactive phase of the MJO. And of course, the inactive phase of the MJO really doesn't feed the jet stream, steals energy from it, and makes it less supportive of storm development in winter months. We can look at 5-day wind anomalies, the Kelvin wave generation again. Again, here's the equator right here. That's the Philippines there. There's South America. So the area we're interested in, Kelvin wave generation area, is this box right about in there. The blue is easterly anomalies. You can see it, January 8th, 9th, 10th, just easterly anomalies. All that is a clear sign of the inactive phase of the MJO. Next, we look at the forecast, 850 millibar zonal wind anomalies. This is just the east-west component of the wind. It tells you whether it's trending more from the east or more from the west. You can see Kelvin wave generation area right between these two tick marks. You go down the chart in time, and you can see we had westerly anomalies. Reds and oranges are westerly anomalies back in around the Christmas time frame. That was the active phase of the MJO. Started falling apart at the end of December. Easterly anomalies started developing, and well, you can see the forecast for the next week. Again, there's the Kelvin wave generation area right between these two tick marks. So right up in there, you can see strong easterly anomalies forecast on the date line, just west of the date line. Again, a clear harbinger of the inactive phase of the MJO. Phase diagram charts, another way to track what's going on with the MJO. Assume you're looking down on the North Pole. The MJO moves from west to east, or from the Indian Ocean over the maritime continent, like Bali, over the West Pacific, across the Pacific, under the U.S., across the Atlantic, over Africa, back to the Indian Ocean. The heavy dot is where the active phase of the MJO is right now, so we're right smack in the middle of the Indian Ocean. The further that is away from this circle means the stronger it is. The forecast track, moving the active phase of the MJO, moving over the maritime continent, maybe starting to make it into the West Pacific 2 weeks out, but very weak at that time. That per the ECMF model. The GEFS model, the ensemble GFS model, pretty much suggesting the same thing. Maybe not as far, as much eastward traction, but a little bit stronger. Here's another way to look at the forecast. This is, the outgoing long wave radiation. Oranges and reds mean more sunlight reflectivity off the ocean surface, meaning high pressure, meaning the inactive phase of the MJO. Blue's the opposite, meaning the active phase of the MJO. Inactive phase of the MJO, right there, there's the Kelvin wave generation area. And it's this per the, this is the statistical model. And basically the inactive phase of the MJO is supposed to be in control, but by about 2 weeks, it starts moving away from the date line. And the active phase of the MJO, you can see it slowly working its way towards the West Pacific. The dynamic model depicts basically the same thing, maybe not quite as strong, but basically the same picture. 40-day upper level model, the green suggests areas favorable for precipitation, and that could be loosely interpreted as the active phase of the MJO. So this is the inactive phase as of right now. This model runs about 2 weeks ahead of what actually goes on down at the surface. Suggests that the inactive phase is moving over the East Pacific and will be out of the picture about the end of January, so at the surface it'd probably be about 2 weeks beyond that. The active phase starts developing January 19th, so let's say that'd be more like, the end of January so, and works its way across the Pacific, moving into South America, let's say the end of February. We're accounting for the 2 weeks here. And then come about the middle of February, the inactive phase shows up again and starts working its way across the Pacific. And then our favorite, the CFS model. Again, 850 millibar winds. These are winds up about 4,500 feet. And just the east-west component of the wind. Here we are today. The forecast is forward. This is all past history here. You can see blues. Those are easterly anomalies. Kelvin wave generation area. 135 east to 170 west, so right around in here. And what do we see? Lots of blues, easterly anomalies. That's a pretty good clue that the inactive phase of the MJO is in control and is only supposed to strengthen over the next 4 to 5 days. Let's overlay the MJO. Sure enough, there you go. The dotted contours are the inactive phase of the MJO. So that's supposed to be in control till about the end of January or so. And then at that point in time, the active phase of the MJO starts showing up. But notice, easterly anomalies sort of lingering here over the dateline region, though westerly anomalies building over the western Kelvin wave generation area. It's not till about February 15th that those westerly anomalies get full coverage in the Kelvin wave generation area. But anywhere, somewhere in this time frame, let's say first week in February or so and beyond, that should be supportive of storm development. The jet streams should kind of wake up at that time, get perhaps a pretty good run of surf in there. And then beyond that, a weak inactive phase is to follow. But notice neither westerly or easterly anomalies, kind of a neutral pattern from there on into April. Why would that be? Well, let's put the low pass filter over here. So the solid contour is, we'll say, the area biased towards low pressure. And look where it was here back in September. It was limited and locked in the Indian Ocean. It's been steadily trying to make its way off to the east. And as we get into about the March time frame, the sense is La Nina is pretty much going to move out of the Kelvin wave generation area. It'll maybe move towards the East Pacific, but the West Pacific is where all the good energy in terms of the jet stream is really generated, because that's where the Kelvin wave generation area is. And so the thought is, come about mid to late March, something like that, this area of low pressure bias will start filling up a pretty good chunk of the Kelvin wave generation area, and then maybe, just maybe, we'll be moving towards a more normal La Nina pattern. All right, so let's take a look and see what's going on in the ocean. This doesn't change a whole lot from week to week, but it gives you some clues what's going on. Here's the East Pacific, here's the West Pacific. We're looking at depth on the equator from 2 degrees north to 2 degrees south, and you can see here's actual surface temperatures. These X's are the anchor lines on the TAO buoys. The X's are the sensors on the anchor line. Then this data is modeled and sort of gives you a profile. Warm water, as you can see, 30-degree centigrade in the isolated to the West Pacific. Very shallow, warm pool in the East Pacific. That's a typical sign of La Nina. Here is differences from normal anomalies. You can see warm water, 2 degrees above normal, trying to push off to the west. You almost think it's a Kelvin wave, but it hasn't made any progress. It's just trying to ease that way. Cooler water in the East Pacific, typical of La Nina, but it slowly is discharging to the surface. Remember, we have strong east trades over here, taking that cool water, pulling it up, discharging it off to the east, and at some point, this warm water is going to slowly start filtering in here and wiping out the cool anomalies. But until that happens, we're still in La Nina. Another version of that same data, modeled a little bit differently, shows the warm water, trying to make it east, but it hasn't passed, we'll say, 140, 135 west, and it seems to be locked there, so we can't call this a Kelvin wave, and there's still a fair amount of cool water here. This needs to all push up and erupt to the surface and get out of here before we expect any major headway there. And of course, what we'll also need is some westerly anomalies, and we don't really have that either. Another clue of what's going on subsurface here, sea level anomalies. This is from the Jason 2 satellite, but it strips out all the waves, all the wind swell, all the tides. So you just look and see where the ocean surface is. It's not a complete perfect sphere. And what they're saying, showing right here is 10 centimeter, maybe 15 centimeter depression in this area. That means cooler water at depth. Cooler water, of course, contracts, creates that little indentation. Here's your warm water here, plus 10 centimeters, plus 15 centimeters in the far West Pacific. So that pretty much reflects what we saw below. But the size of this, and notice all the cool anomalies are pretty much now south of the equator. This seems to be losing some of its toehold, suggesting that maybe La Nina is backing off a little bit. And upper ocean heat anomalies. So here we were last year, some warm water, not really Kelvin waves. Maybe they were weak Kelvin waves late last winter in the March 2017 timeframe, allowed some warm water to build up off of Peru. But then as we got into August, Here was the beginning of cool water setting up, strong easterly trades, upwelling, the subsurface cool pool. This was the core of La Nina. But you notice just right in here, January, here's our warm water building up again here and also making some incursions off to the east, suggesting that just maybe La Nina is sort of losing some of its grip. We've had a pretty good, the past, what was it, in December, a pretty good active phase of the MJO. This might be a temporary or it might be a permanent condition. We're hoping permanent, but we're not going to believe it quite yet. So we look at the ocean's surface now, and there has been a dramatic improvement in the picture here. So we see right along Peru, cool waters, right? But also notice warm waters building a little bit off the coast the whole way down into Chile, up off Peru Nil, and the extent of these cool waters that used to be filling this entire area out here, losing coverage there. This cool water pool that started at the Galapagos and went west from there to almost a point south of Hawaii was much firmly positioned even a week and a half ago and has lost significant ground. The question is this just a byproduct of the active phase of the MJO, or is in fact La Nina actually starting to have lost its top and starting to back off? Too early to know. But the 7-day trend certainly looks encouraging. Look at warming over off the entire South American coast, up into almost Ecuador, and from the Galapagos off to the east, almost no cool pools, meaning whatever's going on, it's all a broad warming trend. And it's right in the area where La Nina theoretically should be doing its strongest thing, and instead it's warming. And now even this view, the 5K sea surface temperature anomaly, temperatures in this region were much cooler even last week and cooler the week before that. Now it's still cool, it's still La Nina, but looking much better than it has. In fact, let's look at actual temperatures. This is sea surface temperature anomalies in the Niño 1.2 region. That's basically off of South America and the Galapagos area. Temperatures rising slightly, but, generally holding in the norm of late. Not a big deal there. But in the official El Nino monitoring region, the Niño 3.4 region, so this is right on the equator, 5 degrees north and south of the equator from 120 west, so basically a point south of, let's say, Southern California, on out to a point out a little bit beyond Hawaii. Here's been the temperature profile. Negative anomalies. We're talking only it takes, half a degree to be La Nina. Half a degree below normal changes the global weather pattern. That's the point here. You can see we've had little forays down to maybe 1.1 degrees, 1.25 degrees. Then just recently we had a big downward spike to almost 1.6 degrees below normal. And now, boom, a big recovery. Today's value minus 0.6 of a degree. So we'll see whether this is going to hold, get warmer, or somehow start falling back. But for right now, the trend looks positive. It looks like we're past the deepest point of our La Nina. So what's the effect of all this on the atmosphere? Well, we look at the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. As you can see, this index, the daily index, was negative back in December. Negative, of course, means the active phase of the MJO, but now we're starting to go on a positive run. Not surprising. The expectation is with the onset of the inactive phase of the MJO, that's what would happen. The 30-day running average sort of tells the same story. We went down to minus 6.6, and now we're starting to recover. We're down to minus 4. That's the impact of positive values in the inactive phase, the MJO, on the index. And then the 90-day average sort of takes all the noise out and gives you a sense of El Nino, La Nina. Positive numbers, of course, are La Nina. And here we are at 3.4. That's not much of a La Nina at all. Of course, we've had this big run of the active phase, the MJO, that took some of the sails out of La Nina, and that's likely what's causing some of the warming and some of this other stuff to going on. So it would probably be a couple of weeks here before we really see how much this starts going positive and what starts happening, whether we get a long run of really positive numbers as we get into the inactive phase to really decide whether La Nina is fading or not. Likewise, the ESPI index, which is really a leading indicator of what might be happening in the atmosphere, is continually losing ground. It was down at minus 0.9 or way deeper than that months ago. This is normally like a 3-month leading indicator of what's going to, or let's say it's an indicator of what's going to happen 3 months out. It is steadily getting more positive, suggesting La Nina is in fact losing ground. And we forgot to show this, but of course, here's the 30-day SOI average index on a chart so you can get some history. Here's the latest big spike of the active phase of the MJO, and that's quite a spike, basically taking us from what was La Nina territory, not into El Nino territory, but at least into neutral. We expect to lose a bit of ground here over the next couple of weeks. It'll be interesting to see, though. We've never in this La Nina gotten even to 15, positive 15. So that's not too strong of a La Nina. Not bad, considering here we were in El Nino. When was that? In January 2016, and we had multiple spikes down below 20. So sort of lopsided in favor of El Nino. And then finally, the Nino 3.4 sea surface temperature index. So they've got some corrected data in here, actual data. And at January 2018, temperatures were down 1 degree below normal in the Nino 3.4 region, the main El Nino monitoring area. And the forecast has temperatures bouncing up to down to minus 0.6 as we get into, let's say, early February. And then basically holding there, and maybe going down to 0.7 as we get into fall and summer, which would still be clearly minimal La Nina, but La Nina none the same the whole way through summer and maybe into next winter per this model. All the other models don't say that at all. They have everything rebounding as we get into April to neutral. So this guy is the outlier, and then maybe even warming slightly as we get into the fall and spring. So a little bit too early to tell what's going on, but this guy is the most negative, the grumpiest of all the models. We're not going to take it with too seriously right at this point in time. So to wrap things up, the active phase of the MJO was really feeding the jet stream. The jet stream's been just doing really quite well lately. We're in a good storm cycle, but the expectation is a week from now, that's all going to fall apart. The jet stream will probably start losing energy. We'll probably split more beyond, and the more the inactive phase of the MJO gets its hooks into the atmosphere, the worse things will get for a while. The good news is it's not supposed to last but a couple of weeks, and then the active phase is supposed to return, and then theoretically the jet stream will wake up again, and we'll be back in business. So we got to take whatever we can get. The other good news is clearly a good, solid, healthy storm has created large swell, which is pushing across the Pacific, making days worth of surf. Hawaii is supposed to have surf for the next, 5 days or more. California, the same. The issue with California, at least in the northern end, is wind, storminess. But hey, rain, snow, we'll take it. We need it. So, and then beyond, we'll see what happens. But long term, it looks like, we're probably going to return to a neutral pattern come this summer. And then we will have paid our price to Mother Nature for our 2 years of El Nino prior to that. So that's it for this week. We'll do it again next week. Same time, same channel. Go get some waves. Go get some snow. Be safe. We'll do it again next week. Same time, same channel.